In this video, we're going to learn how to do a two-proportion z-test in Excel for hypothesis tests. As always, this template without the formulas, right, is available via a link in the description. And let's begin. Like with all of our formulas, the stuff in yellow is the information that you're going to have to provide manually. And that's the stuff that will change from question to question. And then all of these cells will automatically populate with their values depending on, what you change in the yellow spot. Okay, so again, a two-proportion question with stats. With stats just meaning that rather than dealing with an entire set of data where you'd have to, count up how many successes you have in each group and then put the numbers here. They just tell you that you had a sample of 144, and in that group you had 76 successes, whatever that success was, like people with that said yes on a survey question. And then 211 people said yes on a different question, and you're testing if the two sets are, statistically different, and so on and so forth. So the first thing we have to calculate is our first sample proportion, our p hat of the first sample, right? And that is simply equal to the number of successes divided by our sample size. So there's that. And then we'll do the same thing with the second set. So that's going to equal the number of successes divided by that sample size. And then we've got this test statistic of the difference between our two sample proportions. So that's literally just the difference between these two things, right? So it's going to equal P1 minus P2. The reason why we do that as a separate step is there's a lot of questions that will ask us, what is your test statistic? And rather than having to manually do this with a calculator each time, this just always tells us what it is. Okay, then we have to figure out our pooled variance, right? Sometimes called the pooled P, P bar, all sorts of different things, but it's basically this formula down here, right? So we're just going to have to add up the successes and then divide by the sum of the two samples. So we have to remember about order of operations, right? Tops and bottoms of fractions both have to be in parentheses. So it's going to equal, open parenthesis, the successes from that group plus the successes from that group, close the parentheses, then that whole thing is going to be divided by another set of parentheses, and inside that is going to be that group total, right, size, plus that group size, close the parentheses, and there is our pooled P. And then Q, right, pooled Q is always just a complement, so that's really easy, right? That's always equal to 1 minus it, so equals 1 minus that value. And then now we have to do our z-stat. Now you'll notice in the formula down here, we've got our test statistic of the difference in our sample proportions minus the P1 minus P2 without little hats on it. This means we're subtracting the difference between the two hypothesized population proportions. 99.9% of the time, the null assumption is that there's no difference between those two population proportions. So when you do P1 minus P2, you just get 0. And then when you subtract 0, you're not doing anything. It's not, it's not making any change. But if you're going to get into more complex questions where you have to have this, then you're going to need to create another cell maybe down here, and you're going to have to label it, P1 minus P2, and you'll just put in the hypothesized difference, right? We think that there's going to be a 10% difference between these two things. And then in your formula, you're going to have to change this a little bit so that you're subtracting that. I'm not going to bother with that because you're probably never going to come across that. So let's just keep it simple. And again, order of operations, the top is a parentheses, right, divided by the bottom in parentheses, but the bottom is a square root, so the square root, takes the place of parentheses. So, equals, well, we've already calculated that, so that's just this, and we don't even have to do parentheses. But if we wanted to have subtraction with this, all we would have to do would put in parentheses, and then P1 minus, and then, let's say it was down here is where we're going to keep this whenever it comes later, right? And for now, it's just going to be 0, so it's not going to change anything. And then divide by square root. Square root of what? Well, square root of all this fun stuff. And again, fractions. So we would normally have to worry about parentheses and parentheses, but because it's all just multiplication division, we don't have any addition or subtraction. We don't need parentheses, so we can just go p hat, p bar times pulled q, right, divided by the first sample size, and then plus, because order of operations knows to do all the multiplication and division first, so that's why we don't have to have parentheses. Then it's going to add the other fraction. So then it's going to add, again, the same thing, the pooled p times the pooled q, but this time divided by the other sample size. Close that parentheses because that's the rest, that, the end of the square root. There is our z stat. Just like before, if you watched the video, earlier videos where we talked about how to calculate these p-values, to save ourselves some time, it's always easier to do equals 1 minus norm dot distribution, and the x value is our z, comma, 0 is the mean, 1 is standard deviation, and then true for cumulative. But the only difference is we have to come in here and we have to take the, not the square root, the absolute value of H12. And what that does is if we had a negative z, it would then turn it into a positive z, because remember our norm.distribution function always takes the area below it, but we need the area above it, which is why we do the 1 minus. So watch the previous video on a 1 proportion in Excel for a more lengthy explanation of that. But in any case, this allows us to calculate our correct p-value, whether it's a negative or a positive. So for instance, if we changed it up and did a P2 minus a P1, then everything would be negative. We'd get a negative z, but we would still get the same p-value. And then a two-tailed test always just equals this times 2. Okay, so now we have our p-values. We can see they're both really small, so depending on what our alpha level is, and usually it's 5%, we would reject the null hypothesis. Okay, thanks for watching.